How do you design stuff like this, program the CAM software, and mill it all with Alibre Workshop? Let's get into it. If you want to skip, design's at 16 seconds, CAM's at 7 minutes, and milling is at 14:35. Here we have our finished art piece, and we're going to go ahead and roll back in time to show you how you might go through the steps to make something like this. We'll drag the dog bone to the very first extrusion. And while we do this, we want to make sure that we have sketches and reference geometry turned on. So we'll go to the View tab and we'll turn both of those on. So the first thing that I did is I made a representation of my stock. And I don't normally do this, but because I wanted to maximize the size of the art piece, and I didn't know how close I actually wanted it to get to the edge, I figured it would be a good exercise to just model it. The next sketch that I did was actually creating the blank for the art piece itself. And this gave me the ability to kind of gauge how far off I wanted it to be, because I'm not making this to a defined size, I'm just making it to where it looks good to my eye. So to make this, I just created a circular sketch at a defined offset of 0.8 inches from the edge of the stock. Then I made another square around it, such that when I did an extrude cut, all of this excess material between the two profiles would be deleted. At this point, we start to get into some interesting geometry. So to do this, we basically create two hexagonal profiles. And we can create a little bit of reference geometry using this little triangular reference line setup, such that we can offset these in a way that when we pattern them later, they'll all be perfect. Now, when we did the extrude cut for this, we didn't just do a basic cut. What we did was we added a draft angle. And the draft angle can basically take the profile and it'll go inwards or outwards. And we can see that we have -50 here. And so that's going to bring the profile inwards as it cuts. And we can see that we have a little preview at the bottom. So you can play with these angles and the depth and things like that to kind of get the appearance that you want. Now what we want to do is make this happen everywhere. So we're going to go to Pattern, and we can see that we're starting to get some really interesting geometry. But it's only on 1/4 of the object. And we've done this in such a way that it's pretty easy to mirror. So we're going to mirror both the original feature and its pattern across the axis. And then we're going to do that again for everything. So now we've got this really cool object that we can mill. And we were trying to think of a way to make it a little bit more interesting. I mean, this is pretty cool already, but what we did was created a sketch that was basically an arc. And the arc would start at the center, and it would slowly cut away material as it goes. So we're cutting everything in between this little profile here. And the result of that is when we look at it from the side, we get this beautiful domed appearance. And the other effect of that is that due to the way it interacts with the geometry, we get this interesting spacing effect as well, which I thought was pretty cool. So I decided to keep it. One thing I did know, though, is that on the edge, I wanted to have a lip. And some of this was a little bit too busy. I thought it would be cool if we could separate out some of these from being in the model. The way I decided to achieve that was to do something very similar to the way that we cut the model to get this dome shape, but just kind of in the reverse. So what I did there to get rid of this first one, which is the equivalent of these guys, is we just created another sketch. And instead of this first sketch, which we used to cut the top of this, I copied it and pasted it onto this sketch and removed this part of a line and this part of a line and this part of a line. And I just made these extra lines go down. So now we have a closed profile here. And instead of doing a revolve cut, we'll do a revolve boss, which adds material. So our strategy is to have this profile, which exactly matches up with the top of this dome. And we're going to add material in this direction and in this direction so that we can get rid of these three. Now that we've cleared out this section, we can take advantage of symmetry to do the same thing on all of the others. We'll just do a feature pattern here of that revolution that we made. And now we've cleared out most of the edge. We still have a little bit more clearing out to do. These guys here on each of the corners, I want to get rid of as well. And we're going to do the exact same process to do that. So here we can see we've created another sketch very similarly, but it's just offset a little bit. And it's targeting this one specifically. So we'll deactivate sketch mode and the feature will evaluate, and we can see that that one is now gone. And in the same way that we did last time, we're just going to use a feature pattern to make all of the other ones gone. The last step that we'll do is we'll make a revolve with a nice little profile to put a lip on the object, and then we'll add a fillet. And there we go. That is pretty cool. And we can kind of, look a little bit deeper on what's going on by going to the Inspect tab and activating a dynamic section view. Let's turn off our reference planes with Control-Shift-P and our sketches with Control-Shift-K. And we can see that we can drag this and we get this nice, beautiful sweeping profile that should really catch the light in the right circumstances after we mill it and hang it on a wall. It's going to be gorgeous. Now that we're at this stage, we are ready to go into CAM software. So let's go ahead and export this as an STL. Now that we're in MeshCam, the first step, as usual, is going to be to load the STL file that we just made. This is called hexwallhanging.stl. We'll bring it in and we can see that it's flipped upside down. And the reason it's flipped upside down is because when I modeled it, I wasn't paying a ton of attention. And I probably should have modeled the Z positive direction to be the top. But no problem, we'll just click flip and we're good to go. Let's go ahead and accept the change. And as usual, the first thing we wanted to do is to define our stock. We happen to know that our X and Y is going to be 12.75 because that's what we measured our stock piece to be. And the thickness is going to be 0.813. We'll do a fixed stock size, bottom margin of 0 as usual, and that's just going to place the stock at the bottom, or the model at the bottom of the stock. So things are looking pretty good. If you can remember the modeling session, you can see that these are about 0.8 off the stock, so it's looking all consistent. The next step that we want to do is going to be to add supports. And this is going to be a pretty big object. We're going to be using big mills. We're going to go fast. So we want to make sure that we have a reasonable support structure so that when we start to cut things out, it doesn't start moving around on us. So in this case, we're going to go 0.4 by 0.4. We'll place it in the middle of the geometry and we'll press OK. And let's just make 4 of these guys and done. So we can see that we might run into a little bit of a problem here because, I mean, it's not a huge deal, but the very top of these supports is kind of running into this curved part of the fillet. And it's nothing that some sanding won't fix. But why make your life hard, right? So let's go back into our supports. We'll delete all of these guys. And maybe we'll just put it at the bottom of the geometry. There we go. So now we're totally clear of this nice fillet, and we only have to worry about the curvature of this when we get into post-processing later. So cool. So because MeshCam has automatic toolpath parameter generation, we want to take advantage of that. So we want to make sure that our material is defined correctly as wood. And now when we go into toolpaths, roughing, we're going to select our end mill. And we're going to be using 1/4 inch end mills to do the roughing here. So we'll select tool 201. And just because when we created this tool, we're going to turn on use automatic feeds and speeds here. And now every time we insert this end mill into a profile, it's going to look at the material, it's going to look at what it's doing, and it's going to automatically select appropriate feed rates, plunge rates, and other values. Now, of course, you can modify these. These are just suggestions. But if you know your machine and you know you can go faster or cut deeper, certainly do that. Let's go ahead and press OK. And let's calculate our toolpaths. Now that we have this calculated, let's do a quick simulate. And we'll turn off the visibility of the toolpath, and we can see that this is what we're left with. So the point of roughing toolpaths is to take as much material as possible and get pretty close to the actual geometry, so that when we do a finishing toolpath later, that toolpath doesn't have to cut through a whole bunch of stuff. And we want to do this as quickly and aggressively as our machine will allow. Anyway, this is starting to look good. And the only thing that we might want to change here is we notice that we're not going quite all the way through the material. And wood has variation, so maybe it'll go through in some places, maybe it won't, because we're right on the edge. So we can change the max depth that we're going to machine to be maybe 0.83, a pretty minor adjustment. But what that'll do when we calculate the toolpath again is take care of any possible variations in the wood. If maybe part of it's thicker than something else, or our table isn't perfectly flat, and it'll just cut through just a little bit deeper than it expects to. Now, if we were to simulate this, we can see that we're actually cutting through, and this will make it easier to release on the table and have less post-processing at later steps. Now that we have our roughing operations done, let us blaze ahead with our finishing operations. We're going to use 2 finishing operations for this object because the geometry requires it. It doesn't require it, but it makes it a whole lot easier for us. So for flat areas like this, with a little bit of curvature or even just flat, this is great for a parallel finish toolpath. So that's what we want for the top of this. And for things with walls, like these insets or the sides of this fillet, those are great for waterline toolpaths. So let's go ahead and set up a waterline finishing. And we're going to use a 1/4 inch ball mill to do this. We're going to set our threshold angle to be 10. And what that's going to do is just limit the waterline to be the areas that we desire. So let's go ahead and do that. And now for finally, we'll use a parallel finishing toolpath. Same thing with the ball mill. We're going to limit the toolpath to shallow areas and set a threshold angle. And what that's going to do is make sure that this toolpath only stays on the top and on the bottom here, and perhaps even on the top up here. So let's go ahead and press OK, and let's calculate that and see what we get. Okay, so if we look at our only waterline finishing, we see that we have a pretty, it's in the right place. It's only targeting these areas that we want and on the sides, but it's a pretty aggressive finishing operation. And it's not going to leave us with a very good surface finish. You can see how far away these are from each other. So we'll modify that in a second. Let's go to parallel finish. And we can see, as we desire, that it's only going on the top surface of this object. Cool. So let's go ahead and just modify our waterline. And the reason that it's doing that is because the step down is pretty aggressive here. Let's change that to 0.02. And this may make it take a little bit longer, but you know what? I don't want to be sanding inside here. I'd rather it come off the machine as nice as possible. So let's calculate that toolpath again. So here we have everything calculated. Let's turn off our rough and our parallel finish. And we can see that our waterline, let me turn off rapids too. Our waterline now has a much finer gradation. It should produce a much better surface finish right off the table. Sanding in here is just going to be a huge pain in the butt. Anything we can do to avoid that, we want to do. All right, so we have our 3 operations. We'll do a final simulation. Turn off all the toolpath visibility, and we are looking really nice. It's time to save this G-code and head over to the machine. We just zeroed the machine at the northeast or top right corner because we didn't want to run the risk of running into some of these other work holdings with the default bottom left corner. The first operation that we're seeing here is the roughing pass. And again, this is designed to remove material and expose close to the surface of the actual model to a final finishing pass. We're starting to go deeper and deeper into the part, and we can start to see the geometry really become exposed as we drill further and further down. We move now into a finishing pass where we can start to see that the small gradations in our waterline finishing are really paying off because the surface finish from these hexagons looks really nice. As we start to finish up the part, we can see that the rest of the part has had its parallel toolpath already executed, and we can start to see the fillets and the nice curvature that we were going for earlier. We're really close to this part being done. And it is absolutely stunning. With a little sanding and some staining, this part turned out absolutely gorgeous. It's going to be hanging on the wall, it's going to catch light beautifully, and it's going to be a showpiece. And we made it all in Alibre Workshop.